So in that case, for free space, chi E is equal to 0. So epsilon becomes epsilon 0. So epsilon 0 is called the permittivity of free space. Because in free space, there is no material for polarization. So in that case, chi E will be 0 for free space and epsilon will be equal to epsilon 0. And so we say that epsilon 0 to be the permittivity of free space. Okay. Now this we have seen D is equal to epsilon into E for a linear dielectric. For linear dielectric, okay. Now we will see the same kind of thing in case of magnetic properties of the material. Now we have seen that magnetization. See, we have seen that in case of diamagnets, paramagnets and also ferromagnets, if we apply magnetic field to a material, so there will be this material is magnetized. So we define a quantity called m vector. This is the net magnetic dipole moment per unit volume. This is called the magnetization vector. M is the net magnetic dipole moment per unit volume of this material. Okay. Now, of the material. Magnetized material. Okay. Now, we define a quantity called H vector. H is equal to 1 by mu 0 B minus M. So, we define a vector, that is H vector, that is 1 by mu 0 B minus M. Now, for linear medium, this H vector is proportional to the magnetization vector for linear medium. And similarly, we can insert a proportionality constant. H is equal to chi m into m. And this chi m is called the magnetic susceptibility. So, chi m is called the magnetic susceptibility. So, chi m, this is a dimensionless quantity, magnetic susceptibility. For diamagnetic material, chi m is a negative number, and for paramagnets, it is a positive number. Okay. So, if you use this relation in this expression, H is equal to 1 by mu 0 B minus M. Now, in place of see, one mistake I have done. M is actually proportional to H. So, M is equal to chi m into H. This is the actual relation. So M is proportional to H, magnetization, since in case of electric properties, we have seen that polarization is proportional to the field. So here magnetization is proportional to H. So M is proportional to H. So M is equal to chi M into H. Okay. So here if you put chi M into H, so please correct this thing. See, M is proportional to H. So M is equal to chi M into H. Okay. Now I can bring this term on the left hand side. So H is equal to 1 plus chi M equal to 1 by mu 0 B. Okay. So I can write, please correct this thing, M is proportional to H. So M is equal to chi M into H. Chi M is the magnetic susceptibility. Okay. So B is equal to mu 0, I can multiply with this term, mu 0 into 1 plus chi M H. Okay. Now this I can write, or B is equal to mu into H. Now what is mu? Mu is called the permeability of the medium. So mu is the permeability of the medium. So mu is equal to mu 0 into 1 plus chi M. So what is mu divided by mu 0? So mu divided by mu 0 equal to 1 plus chi M. This is called the relative permeability. Relative permeability of the medium. Okay. So in free space there is no material for magnetization. So in free space chi M will be equal to 0. So mu is equal to mu 0. So we say mu 0 to be the permeability of free space. Okay. So with these ideas, now we will go to the wave equation of the electromagnetic field in material medium, mainly the dielectric material. So we need the Maxwell's equations in material medium. Maxwell's equations inside matter. One, that is divergence of D is equal to rho F. This is the charge density for the free charge carriers. 2, divergence of B is equal to 0. 3, curl of E is equal to minus del B del T. And 4, curl of H is equal to JF, that is the current density vector due to the free charge carriers, plus del D del T. Okay. Now, in the region where there is no free charge carriers, in that region rho f will be 0 and jf will be 0. So in region where rho f equal to 0 and jf equal to 0, Maxwell's equations are one, this del dot D will be equal to 0. Now, for a linear medium, we know that D is equal to epsilon into E. For linear medium, D is equal to epsilon into E. Now, we will assume that the medium is also homogeneous. Homogeneous means epsilon, that is the permittivity of the medium, does not vary from one point to another point of the medium. So, for homogeneous medium, for homogeneous linear medium, epsilon is a constant. That is, it will not vary from one point of the medium to another point. So, homogeneity means the property is same through for all points of the medium. So, epsilon will be constant. So, if you write, so then divergence of epsilon into E will be equal to 0. Now, since epsilon is a constant, this del operator in front of this del operator, epsilon will be a constant. So, this implies del dot E equal to 0. So, this is for linear homogeneous material medium. This is the Maxwell's first equation. Okay. So, Maxwell's second equation, it remains same. It remains same. So, Maxwell's second equation, that is del dot B equal to 0, it remains same, and this is equation 1, Maxwell's first equation for a homogeneous linear medium. You have to remember that this equation is for homogeneous linear medium. Okay. Now, Maxwell's third equation also remains same, that is del cross E is equal to minus del V del T, and Maxwell's fourth equation becomes del cross H. Now, I have told that Jf is 0. We are writing the equation in the region where rho f and Jf are 0. So, curl of H is equal to del D del T. Okay. Now, we have seen that for a linear medium, H B is equal to mu into H. We have seen that, where mu is the permeability of the medium. So, we can write this equation as, and also D is equal to epsilon into E. So, we will write this equation in terms of these two equations. So, for a homogeneous linear medium, for a homogeneous linear medium, mu will be constant. It will not vary from one point of the medium to another point, and epsilon will be also a constant. So I can write this equation as del cross, now H is 1 by mu B, and that is equal to del T of epsilon into E. Okay. Now, see, I can take mu outside the curl, so I can write, so 1 by mu curl of B, that is equal to epsilon del E del T. See, so what do we get? We get, or del cross B is equal to mu into epsilon del E del T. So this is the Maxwell's fourth equation. This is the Maxwell's fourth equation for a linear homogeneous medium. Okay. Now again we can, now to derive the wave equation, we have to take the curl of both sides of this equation and also of equation 3. So we start with equation 3. So equation 3, or of Maxwell's equations is del cross E is equal to minus del B del T. Okay. Now if you take the curl, del cross E is equal to minus del cross del B del T. Now like our previous case, this is gradient of divergence of E minus del square E, this is equal to minus del T of del cross B. Okay. Now this is equal to 0, and del cross B I can take as mu epsilon del E del T. So we will have or minus, this minus I can cancel from both sides. So del square E is equal to, now in place of del cross B you can write mu epsilon del E del T. So we will have mu epsilon del square E del T square. Okay. Now if you call V square as 1 by mu epsilon, so this equation becomes, V is the velocity of the electric field vector through the medium. So this is del square E is equal to 1 by V square del square E del T square. So this is the wave equation of the electric field inside material. See here, this V is equal to root over 1 by mu into epsilon. This is the permeability of the medium, and epsilon is the permittivity of the medium. Okay. Now we can take curl of both sides of this equation. So if you take curl of both sides of this equation, now take curl of both sides of this equation. So del cross B is equal to del cross mu epsilon del E del T. Now since we are dealing with homogeneous medium, so mu and epsilon are constants in front of this del operator, so they can come out, and on the left hand side we will have gradient of divergence of B minus del square B. This is equal to mu epsilon. Now I can insert curl here, so it is del del T of del cross E. Okay. Now this term is 0 because del dot B is 0. Now from Maxwell's third equation, del cross E is minus del B del T. So I can write down minus del square B is equal to minus mu epsilon del square B del T square. Now you can cancel minus from both sides, so we get del square B is equal to, now mu epsilon is 1 by V square. From here you can see, so it is 1 by V square del square B del T square. So this is the wave equation for the magnetic field. So these two equations are the wave equation of the electromagnetic field through a linear homogeneous material medium. Okay.